All right, so for this one, we have an electron has initial speed of that, uniform field between parallel plates, assume the field between the plates is uniform and downward, and the field outside the plates is 0. The electron enters the field midway between the plates. The electron just misses the upper plate as it emerges from the field. What's the speed of the electron as it emerges from the field? Okay, so they kind of gave you a hint already with the picture. The first thing I would normally ask you, if the field's going straight down and it's electron, what's the direction of the acceleration? Yeah, it's positive charges will go with the field, negative charge will go against the field. So the acceleration straight up. And they kind of made it easy because the initial speed is horizontal. So we can kind of say, okay, well, all of the vertical motion is just from what happens with the electric field. So that'll kind of make our lives a touch easier. Whoops. Let me get out of that. Let me close that one. Minimize that one. Okay. And pull my problem back up. So we have, so let me just look at the vertical first. So we're moving a distance of 0.5 centimeters. So if you remember back from first semester, I mean, this is a constant electric field, so you have a constant force, which means you have a constant acceleration. What's the equation you jump to when you have a constant acceleration?
You know how long it's been subject physics one.
Yeah, but you've been taking all these engineering courses, which are just physics 1 over and over again.
I don't know about that.
Okay.
Physics 1 with calculus, maybe.
So in the y direction, we've got no initial speed, so it's just y is 1/2 at squared, right? In the x direction, we have no acceleration because the field's going straight down. So it's just going to be x is v naught t, right? And then going back to our picture, the y distance we were moving was 0.5 centimeters, so 0.005 is 1/2. We're going to figure out a here in a second, so let me leave it out for just a second. And then x, what was x? So x is going 2 centimeters, and we do know our initial speed is 1.5 times 10 to the 6th. So 0.2 is 1.5 times 10 to the 6th t. Right? And as far as finding A, we kind of did this last time. So on one hand, force is mass times acceleration. On the other hand, since we have a uniform electric field and whatnot, it's Q times the electric field. Right? So if I go back, I mean, it's an electron, so we know what the mass and the charge are. The field, they gave us the field, didn't they? They never gave us the field, did they? Okay, that's okay. We can do. We're still okay. Apparently, I erased my 0.5 somehow. Okay. Oh yeah, we're fine because we can get T from this one, and then use that to get A in the other one. So we don't actually need to know that, but it's still good to know. So I'm glad I wrote it down. All right. So T is 0.02 divided by 1.5 times 10 to the 6th, which is whoa, that's completely not right. There we go. So 1.33 times 10 to the negative 8 plug that into the other one. So my A is going to be multiplied by 2, that's 1. So 1 divided by t squared. So my acceleration is, so that's squared, and then 1 over x, big number, 5, 6, 2, 5. Times 10 to the 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so I know my A and I know my, yeah. I know my A and I know my T now. What it was looking for, it was looking for the speed as it emerges. Is that the only part to this problem? Yes, this is only one part problem. Okay, so that means we kind of already got everything we need. Because the other equation that went with this, I mean, your y is 1/2 at squared, your x is b naught t. Well, if you look at the speeds, the speed of y is at. The speed of x is just the initial speed, right? And again, that's because there's no acceleration in the x direction, so it doesn't have an a on it. Same thing, there was no initial speed in the y direction, or else you'd have a plus v naught y or whatever. But for this one, that's all we got. And so the speed as you're leaving is square root vx squared plus vy squared, which is square root. Vx was 1.5 times 10 to the 6th. Vy is at, so 5.625 times 10 to the 15th times 1.33 10 to the minus 8th squared. Okay. So we're nearly there. So this guy times, whoa, I hit 8 instead of times. That's sad. Do it again. 5 point. Let's do 625 times 1.33 times 15 and negative 8 is 7, so 7. So that's my Vy squared plus 1.5, oops, times that squared equals square root. I got 7.48 times 10 to the 7th, if my calculator skills are okay. Which seems kind of reasonable since I started at 10 to the 6th, so let's try it. Oh, made a mistake somewhere. But when you see what to do. So anyway,
Right.
Normally I would try to fix it, but it's 10:55 or 8:55, so it's kind of time to quit.
In other words, we don't want to worry about those.